What are they? Everything is AI, this, AI, that. At work, we had a meeting about using AI that which ones are private, which aren't. You know that some of them are public, right? When you do like ask a question, they record everything you're whatever. So, when you work for a company, they don't want all their important information public. So, so I think there's different types of AI. Anyhow, who knows? Uh, yeah, as far as I'm concerned, though, AI is not good because it does lots of bad things to your brain.
The water usage.
What?
What's the water usage?
I'm sorry?
Like the data centers, the cooling, the water cooling, it uses a lot of.
Oh, oh, you mean because he uses, yeah, but yeah, even without all that issue, just the fact that it's just like it just makes it, like I saw in a bunch, uh, like they said, like I don't know, like a lot of YouTube things, they're all AI. I mean, you could hear it's like a computer speak.
The data of the.
Yeah, like half of them you click on there, somebody just like they took an article and they made a YouTube out of it, text to speech, and then they generate some images. So the whole thing is fake. Yeah. Like it's not a real YouTube channel at all. It's just like, and the other half of them just they copy other ones. So basically what's happening is that AI is learning from AI. So it's kind of silly. After I heard that there's a problem. Like if everything's going to be generated by AI, so then eventually AI learns from the internet. So they'll be learning from itself. So, so like there's a limit till they, what it could learn, or eventually it'll be learning from itself, which is, you know, kind of pointless, right? Um, okay, so I did upload. Um, so let's start with this, okay? Did anybody have a chance to look at the sample midterm? Well, we'll do it now, okay? I'm not just going to review it. I mean, I'll ask questions as we go, so you'll see it's a good review. Okay, and then whatever we don't cover today, I'll do it like 7 p.m. on Sunday on Zoom, okay? So, and I'll record it, okay? But you won't have much time, you'll just have to review.
Quick question.
Okay, so functional versus non-functional, right? So does anybody remember what the difference is? What is a functional requirement? This is like from chapter one. What is a functional and what's a non-functional requirement? Right, you see the answer here. It's requirements, but what's the difference between them? Yeah,
Non-functional was like thing that's implied that customer didn't say specifically.
they said, right, they specifically,
Not,
oh, that's non-functional.
Yeah,
Yeah, non-functional is what's implied, right,
functional is what they say specifically.
right. And functional is what they asked for. And also non-functional is usually something that's what? That's like usually it involves more, it's like a general thing that involves many things, right? So for example, security is a non-functional, right? Anything ends with a Y is probably a is probably a non-functional, right? Security, maintainability, stuff like that, efficiency. Stuff that's general, right? Okay, just we didn't really cover this. Oh, I have to plug this in. Does anybody know what a prototype is? You probably all know what a prototype is, right? It's like a mock-up, right? What a prototype is like if you make a mock-up of something. So, and then you show it, and then based on that mock-up, that's what's a prototype. It's not really working, but it gives you an idea what you're doing. Testing, that is architecture is, we didn't cover that really yet, but that's like basically a general, like the big picture of how the how the software is um, is structured. Okay, we'll see later on, but what that exactly means. But architecture basically part of the, what phase would that be? Is this before or after coding? When do you do the architecture? Right, before or after requirements? Right after, right. So first you get the requirements, then they do the design, which includes architecture, and then you do the coding, right? We're talking about, let's say, waterfall. Um, well, even all of them, actually, you do in that order. It's just that with waterfall, you do all the requirements, and then you do all the design, then you do all the coding, and then you do all the testing. Maintenance, what does that mean? What does that refer to? If, what's maintaining software mean? I'm sorry? Right, right, okay. But what, oh, actually, okay. What is maintainable software mean? If I say software is maintainable, what does that mean? You're means it's easy to maintain, to fix, right? Basically, it means yeah, the way I just said, it's maintainable means easy to fix, which usually means that it's clean, it's nicely laid out, it's not a bunch of if statements and, variables all over the place that it's hard to understand what's going on, right? Um, okay. Forget about the numbers. Um, the benefits of using cloud software. So what is cloud software?
It's in the cloud.
What?
They have in the cloud.
Right, right. So basically, you don't have to install anything on your computer, right? It's running on somewhere on a server somewhere in the world, right? So, right. So, so it's all the above, basically, right? So no need for maintenance, meaning that for the clients, right? Meaning that they don't have to fix it because it's available because it's, again, in the cloud, scalability, which means that you don't have to worry about, that if you install something, it's scalability mean, oh yeah, I should explain what these mean. Availability means what? That it's what? What?
Safe to use,
What?
usable, you can use it.
No, available. It's available means that it's, in other words, it doesn't go down, right? Not like AWS went down 2 days ago, right? Right. Supposedly there's supposed to be like up 90, you would think AWS would be really, yeah, really, really available, but they messed up something. Okay, scalable software means what?
It can expand or contract.
Right, meaning that, what does that mean with software? How does it span?
Memory and usage CPU.
Okay,
Add
but
features.
but that's more like a technical description. But scalable basically means that you can have more users. It's capable of handling more demand. Like, for example, like come uh, you know, pretty soon it's gonna be like Thanksgiving, Black Friday. So all the websites have to be scalable because they're gonna get much more demand than normal, right? So they all have to be able to grow because if users can't, buy stuff on it, then they're gonna look, that's their whole business, right? The whole business is that that people could go to the website, order something and click on it, but if they can't, they'll just go to another website, right? Uh, like I was just on a website, when was it, yesterday? And they sent me a coupon code and then I typed it in and it didn't work. And I said, forget. They said it's not available. I said, what do you mean? I gave you my phone number and yeah, I gave you my phone number, my email address, and you're not giving me any. And then I blocked their text messages. Yeah, I'm done with them. So, yeah, so that's, okay, so, oh yeah, so availability means it's available, meaning that so basically if it's not on your server, so then you have to worry about availability. Usually commercial cloud software is, they're very careful. They have, if one goes down, you go to another server somewhere else, right? Like I think in Amazon, you could specify where you want your servers and your backup servers. So it should be available. Scalability, we says ability to grow, less staff required. That means, but meaning that if we're using software in the cloud, then we don't have to, we can hire less people, right? So it'd be basically all the above, right? Um, okay, so that's the benefit of cloud software. Um, okay, the strategy pattern, right? The main idea behind the strategy pattern is that we're replacing, instead of inheritance, we're using composition, okay? Right, which means that rather, just do it in code, like, let me just, well, I can just do it here. So for example, with inheritance, we would say something like class, no. Um, um, I'm trying to think. Let's say I have um, uh, let's say animal. No, that'd be, uh, let's say I have a, um, let's say, I'm trying to think. Um, let's say I have a class called Queen's College, right? And then I have another class called, um, let's say, Queen's College and Queen's College Computer Science Department, right? And let's say I would say it extends Queen's College, right? So this would be a case of, um, oh, I put over here, I think this is technically correct. Okay. So this would be a way you would use, could you see this? So this would be a way that you do inheritance, right? So I may, when the science department is able to use the Queen's College object because it is a Queen's College, right? But in reality, it's not really a Queen's College, right? You might want to use some of the features. So the better way so this way is too strong, right? Because really the science department is not Queen's College. The whole Queen's College has security, has gates, has parking lots. The science department doesn't have any of those, right? So it doesn't really need all this stuff, right? So it's not really like, it doesn't, you might want to use some of these things that belong to the Queen's College, right? Maybe you want to use, I don't know, something like you want to use I don't know, maybe you want to use their attendance records or something, right? The student roster from Queen's College, right? Just in general, we want to know if the student is the enrollment roster, but you don't really need the rest of Queen's College, right? You don't need to know what the people's salaries are, stuff like that, right? All that stuff you don't need. So the better way to do it would be instead of inheritance, we would do it like this. We would say the object over here is going to be Queens College. I'm sorry, Queens College Science Department. And since we want to have the Queens College object, so we would do composition, which means we would put Queens College inside of, in, um, inside of the science department. Right? Something like that. So you see over here, we're not getting everything from Queens College, but we have access to it. See, that's the difference. Over here, we inheritance means we are Queens College, so we're getting everything whether we like it or not. But over here, it means that we can access Queens College, but we're not Queens College. So we're not getting, so we could do, so for example, let's say Queens College has their, let's say they have um, a bulletin board, right? I'll just make this, make it simple. Let's say they have a bulletin board. How you spell bulletin board? Um, Whatever. So then over here, oh, it's gonna fix it for me. Okay, bulletin board. Right, you know what a bulletin board is, right? What just happened? Huh? What just happened? Oh, so let's say, oh, so let's say Queens College has a bulletin board. So now the computer science department is automatically going to have that bulletin board, right? But let's say it wants to have a different bulletin board, right? So if we do it like this, or let's say you want bulletin board to be a different type. I don't know. Say you want bulletin board to be type bulletin board. I don't know. Oh, I shouldn't leave a space. Sorry about that. And let's say over here, we want this to be like this. So in this case over here, oh, let's copy that name. So in this case over here, over here, if I want to have over here, if I want to have my own bulletin board, it's going to conflict with this bulletin board, right? Because this is a string, and over here it's an object, right? But in the second example over here, I only use what I want from Queens College, right? So I don't want to use their bulletin board, so I just make my own bulletin board, right? So there's no conflict. I don't have to worry about conflict because I'm not using the bulletin board part of Queens College, right? You understand what I'm saying? So, right, so example over here, I would not be able to do this. It would probably, I don't know what would happen, but it would definitely cause confusion. I think this would not work. I think if you did this, I think this would be a problem, right? I doubt this would work, or at least be confusing. This will probably not work. I didn't try it, but it, whatever, it'll definitely cause confusion, right? Because Queens College has a string as a bulletin board, and and now I'm redefining it as something else when in its child. So it's fighting the parent. But over here, I'm not fighting the parent because the parent, I only want to use, if I want to, I could say something like, um, I could say, if I want to, I could use the bulletin board, but I don't have to, right? So I could do something like Queens College dot bulletin board if I want. Or actually, I could have two of them, but I could use both of them, right? So I could do, let me get what's happening over here. Oh, because great. So over here, I could have my own bulletin board, or I could use a Queens College. I have the options, right? But over here, I probably have to use this bulletin board, right? I don't even have the option of using my own bulletin board, right? So you see, it's better to have, you have more dependent, you have all the functionality of Queens College without the drawbacks, without being forced to do anything. Does that make sense? Right? So if you're doing composition, you have more you're not forced to do anything you don't want to do, right? You just have availability without so you get the best of both worlds. You could use Queens College object, but you're not forced to. Okay, so that's the idea of composition. So initially, people thought, "Oh, inheritance is really great," and then they realized it's not so good because of things like this, where the parent does something a certain way, then the child is sort of stuck, right? They would have to probably rename this like my bulletin board or something, so there's no conflict. Um, Okay, so that's the explanation of the idea of the strategy pattern is that we're not inheriting behavior, we're getting it. In the case of strategy, we're passing it in, right? You remember with the duck, we passed in the strategy, the behavior as an object, rather than inheriting it from another object. Okay? Okay, so we're up to, okay, any questions? Okay, if you have any questions, just ask. Okay. Um, okay. Uh, okay, whatever. I just this um okay. Okay, so um okay. So over here, what's the question? Yeah.
So what was the question for the guy? Do we get to just draw a class like that, or we have to?
No, I just wanted you to understand what I was saying.
Oh,
Yeah, the idea of the strategy pattern is we rather have composition over inheritance, right? Um, So I'll just explain what that means, because it's easy to say it, but yeah. But it actually, if you explain it, then you actually understand it's sort of like I used to like just like say it, but unless you actually try it, you see the difference, right? Um, Okay, geometry, the above code violates, what's wrong with this? Actually, I asked this on a job interview for my company. I was interviewing somebody. So over here, which object-oriented principle is being violated? I mean, it works. Area is height times width, and volume is area is height times width times depth or volume, whatever it is. So this is correct, right? So, but this is violating a certain object-oriented principle. Yeah, which one?
I forget the name, but it's the one, basically instead of int area equals height times width, you should use the previous like
Right.
area.
Right.
Bracket.
Right. So this stands for, derive stands for what? Yeah,
Teach yourself.
exactly. So over here, we're repeating
Yeah.
height times width, right? Right? So what should the code say? It should really be what? It should really be, I'll just write over here so you understand it. So it should really be what?
The function area bracket.
Yeah,
Height width.
right. Actually, it should be area, right, height. Um,
You could return actually, can't you do it in one line where you do return?
yeah,
that
times depth,
Depth, yeah.
right, right.
Return all
And
that.
just do return, right. Really I'm sorry, I got mixed up. Return, right. Yeah, where I work, we try doing everything in as few lines as possible because We're cool. I don't know why, but we did it. Like whenever I do something in 3 lines, they could do it on 1 line. I get yelled at. Why not doing 3 lines? Why not doing 1 line? And for some reason they think it makes the code easier. I don't know. So it should really be, right, should really be really reuse the area method from above. Okay. So that's what does Yagni mean, by the way? Yagni means like get rid of old code. Remember why we said you should do that? Yeah, I'm sorry. Yagni stands for you aren't going to need it, right? You're not going to need it, so get rid of it, right? Now, why is that?
Because if you don't need the code, it's just taking up unnecessary space in the program, right?
Well, we don't care about space. It's cheap. Space is cheap. Right? There are two reasons.
You
What?
reduce the clutter.
What?
Don't you, they also reduce the clutter, like in the,
Okay, what do you mean by that? So,
like, if there's code in your program that you don't need, like, there's no reason to keep there, it's just, like, it's just making, like, anyone who has to review the code, just giving them more stuff to read over, which is not.
okay. So, I mean, the argument to keep it is, well, I already spent, I spent my money on this programmer to write this code, or the programmer spent this much time. Why should you delete it, right? So the answer is number one is what you were saying. Basically, it's confusing when unused code, put it underneath it. Maybe we'll make this a 1, I guess. When it's confusing, come on. It's confusing when unused, why is it doing that? I don't know. When unused code is, when unused code, or it's confusing because other people think the unused code is, I don't know why it's doing this, still being used and waste time looking at it. Okay, so that's one problem. The second problem is that when you leave something around, it's not free. It sounds like, well, I wrote already, let's keep it. But actually, there's a cost involved, right? So even though it's not being used, we still have to maintain it, right?
It's that way,
What?
it's that way,
It's, would you say dead waste?
yeah, definitely.
Yeah. So we have to maintain, we're wasting money or time, whatever, maintaining unused code, right? So it's sort of a waste. Okay, so the two reasons to get rid of Yagni, right? If we don't need it, get rid of it. It's just confusing. And of course, nowadays we have, you're familiar with GitHub, right? So you keep a copy anyhow. So if you ever want to know what it was that you used to have, you could always go back and find it. No one ever does, but just in case your conscience says, but maybe I might, it was such beautiful code. I want to, you could always go back and get it. Even if you permanently delete it. Notice, I think in Git, nothing is ever permanently deleted. You can't, there's always a way to get it back. Even if you delete a repository, there's a way, it's still in there somewhere. So, okay, so dry is, don't repeat yourself. Depends the inversion. What does that mean? Then remember, depends the inversion principle. means that, I mean, we're not gonna explain exactly what it means, but we're gonna, well, I mean, practically what it means is that what? That we should always use the most abstract type we could get away with, right? In other words, the more specific, the more concrete your types are, then the greater the possibility you have to modify it later on. So the more, right, sort of makes sense, right? So for example, if I use like a standard size tire on my car, then it's really easy to get a new one, right? I could go to the store and I could pick any of, 20 different tires, right? Because I have I have a generic type of size tire. But if you have a very, like I just saw somebody has a bike with a 29-inch wheel, right? That's very, I've never seen that before. So that's gonna be a bit more difficult to replace it, right? So the more the dependent version says, always be as generic as possible so that if you change something, it's not a big deal, right? You won't have to change code, right? So be as generic. In coding, what that means is rather than an abstract, rather than a concrete object, maybe type, we should use like a interface or a parent class, right? We should be as as we should be as as less we don't, the more exact we are, right, then the more trouble we're gonna have later on when we make changes, okay? So in other words, so like if I have a car that only uses, let's say, a Tesla and only uses a certain type of tire that only Tesla makes, or there's only one type in the world. So then if I get a flat tire in a Tesla, then I'm like, then I have to go find and open someone who has Tesla tires, right? But if I have a general tire, which, millions of many different cars use it, so then it's very easy to change, right? So, and I don't have to get a new rim if I, it's all, everything is interchangeable. It's much more generic. So be as generic as possible. Okay. Okay. When using object types. Okay. Liskov substitution, we said, is basically, does anybody remember Liskov substitution? That the child, if we use the child object, it should not give a different result than when we use the parent, right? So child object should give the same result for same method as its parent. Okay. Okay. And then the single responsibility principle is that what? That this is pretty, yeah,
Function should, yeah.
right, right, right. So we should keep things simple, basically, right? There's, okay, there's two reasons for this, actually. What, remember what they are? Uh, Meaning that code should only do or an object should only do one thing. And if it, right, and there's two reasons for that. Number one is it's just simpler, right? Because then your code is simpler, right? If he only does one, right, if it only does one thing, then it's easy to understand, it's easy to write. And number two is if it's doing more than one thing, so then you're increasing the possibility that it's going to need to be changed, right? Because so the less something does, not something, an object does, the less chance it will need to be modified later on. So basically, no, so basically, if I have no, if I have an object that does three things, so then it has three times the chance of being modified as opposed to an object that does only one thing, right? So, right, because I'm increasing the more thing an object is going to do, then there's, obvious, it's more, and so, but if I split up into three different objects, so then when something gets changed, only one of those things is going to be affected, not all three, right? Right. Does that make sense? Like, right, we said, Leslie, something like if I have a method that adds and then emails something, so then if I want to change the emailing or the adding, then I might break the other thing, right? So, but if I have two separate objects, email and printing, adding and emailing and printing is another object. So then when I change one object, I'm not going to break the other two, right? Because they're separate from each other. So that's the idea of having just doing one thing. Okay. It sort of makes sense, right? Um, does that make sense, right? Like let's say I want to, um, right? So like, for example, if I have if I have a computer, right, which it has a CPU and this and that. So when you open it up, you could, when you're changing one thing, you could break something else, right? But if I have something that only does, it's a separate component, I pull it out and plug another one in. The memory, let's say memory is a memory card, I just pull it out, plug another one in. So there's much less chance I'm going to break anything else, right? So okay, that makes sense. Okay, so over here is actually an example of what we have a bug. Yeah, so we have a medical record which has a database object inside of it. Okay. Um, Okay, okay, let's see what's going on. By the way, so let's just look at this class. What's the relationship between medical record and database? Yeah,
Database is an attribute of record.
okay, or it's inside of it, right? Or composition basically, right? For our purposes, we'll call it composition. So medical record composes the database object, right? And then when you create the medical record, you pass in the database object, right? That's how we set it up, right? Okay, so first thing I wrote was medical record and database is a relationship. No, they have what type of relationship? Has a, right? Medical record composes the database. We just said that, right? Database is encapsulated. Now, this is a tricky one because encapsulation means what? It protects it. Now, this is public, so even though it's inside a medical record, it's not protected. Meaning anybody could go in to any outside object, could just change my database, right? I'm not in control of it, right? So false because because database is public. It's a little tricky one. Okay, sorry about that. Um, Medical record is dependent on database. That's true. Meaning that database, as far as we know, doesn't need medical record, right? But, database, as far as we know, is like up here, for example, what happened up here? Huh? Oh, so for example, over here, here, for example, over here, we're just looking at, oh, it's doing this to me. Here, so over here, we have Queens College, which has a bulletin board inside of it, right? So over here, Queens College needs this type, it needs a string type, right? Or you couldn't have a bulletin board, but string doesn't need Queens College. Does that make sense? So the dependency is you have string at the bottom, and then Queens College above it, because Queens College needs string in order to exist. So over here, we have the same idea. We have a medical record, which it has database. So at the bottom would be database, and on top of it is medical record, which needs database in order to exist, right? That make sense? In other words, database doesn't need medical record, but medical record needs database, right? Database, you can have a database without having a medical record, right? But you can't have a medical record without a database. So I wrote medical record is dependent on database. That's true, right? There's a dependency. Medical record and database has a relationship, which we just said, right? Because inside medical record is the database object, right? Does all this make sense? Any questions? Okay, let's keep going. Which of these do not involve incremental development? Okay, so remember I said that in the book, chapter 3, they just reuse different words, but for our purposes, we call all of them incremental. They're all the same. So if you say any of these, or anything except for number 4, they all mean the same thing. So they're all the same idea. So extreme programming, agile, scrum, iterative, it all means the same thing, is that we're producing a little bit of software at a time, right? We do a little, we every 2 to 4 weeks, we produce a little, we add a little more software as time goes on, right? Software reuse, right, doesn't involve incremental development. Why not? Yeah. We're not coding. Forget about it, right? We're not even writing any code. We're just reusing someone else's software, right? We Google accounting software, and we find something that works, and we configure it, and we're good to go. So we're not involved with any thought. We're not involved with anything. We're not doing any development, right? We're not doing testing. We're not doing design. We're not doing architecture, right? We're just doing, what do we do for software reuse? We do requirements and basically configuration, right? That much we're going to have to do something a little bit. Now, we'll have to set it up for our company, right? Because you have this big program, Salesforce or accounting, and you're using it for your company, but so you probably have to configure security, who has what rights to do different things, but that's about it. There's no coding, there's no testing, right? If there's any problems, you call them up, call it 1-800 and say, you complain, right? So software use it does not involve development altogether. So that's the beauty of it. That's why we said that software reuse is always the best way to go. Because if you have already existing software, don't waste your time reinventing, it's reinventing something that's already, you could already use, that's already written and tested. Okay. Which design pattern uses the principle open for extension, closed for modification? So we said that means is that when we when we modify in other words, it's always better to add code than it is to modify code. That's what this means. Open for extension, closed for modification. Meaning that if we want to add more functionality, it's always the best way to do that is by adding more code or creating new objects, right? Why is that? Because if we're adding more code, and we're not changing the existing code, then that means we don't have to retest everything, right? We don't break but stuff that was already working. So it's always the safest thing to do is just to extend it. So for example, with the observer pattern, what do? We just created more types of observers, right? We never had to change anything else, right? Let's say we had, in our example, we had let's say we had was a government agency was watching the stock market, right? So if we need another observer, let's say a journalist, let's say the Wall Street Journal wanted to observe the stock market. So we didn't have to change the previous code. We just added a new type of observer, right? But we didn't have to modify anything that existed before, right? Everything else stayed exactly the same. We just added a new type of observer. And the standard strategy pattern is we had, let's say, a duck, and we just passed in a new type of strategy, right? A new way of flying, but we didn't change anything that existed before. So that's always the best type of development because it's safe, right? Because we're not keep on changing code, right? And so that's always the best thing to do. Like there's one guy at work who he hates when I sometimes when I write whenever I look at code, I always like try cleaning it up, and a lot of times I make a lot of changes, but they're not like brain surgery changes. But there's one guy who says, "Oh, I see there's like 50 changes here." It means like 50 lines were changed. He says, "Too many changes." Yeah, like he gets nervous every time he sees a lot of changes. Oh, you know. So, but but I like cleaning things up. I don't like, you know, I don't like stuff that this stuff lying around. So a lot of times I change stuff. So depends. So I try to if I'm doing something that where he's involved, I always careful not to make too many changes because he gets nervous. Yeah, he says he changed. Oh, he just checked in this. The code has many changes. Does anybody realize how many changes he made?
No point to like make changes and update the code, make it more efficient over time.
Right, but there's potentially you could break it. So he gets really nervous every time I change things. So it's better if you could add code rather than modify existing code, right? When I say add code, I mean like create new objects, right? When you create your code in the first time, you should allow it so that when you want to change, let's say for accounting, like let's say every year you have a new way of determining the tax. So you should make it so that the parts that change are passed into it. So the next year, you don't have to change the previous year's code. You just make a new object and you pass that in, right? You see what I'm saying? So rather than just having one set of code and modifying it every year, you would pass in different code every year. A newer object. Like you would have a 2025 accounting object, 2024, 2026, etc. So you would have a new object rather than, but it wouldn't be changing previous code.
So the idea is to make the code more flexible and like adaptable to this and stuff like that.
Well, it's simpler. It's just like I'm not changing anything. So I'm just adding. So whenever you add, the only thing you could break is a new code. The only thing I have to test, right? Because if you have a program which is lines of code all over the place, right? And then you make a change, you never know what's going to break. But if you're just adding code, right? So you don't have to worry about that. It makes a huge difference. So so the idea is to design the code so that the parts that change are passed in rather than they need to be modified. So if they're passed in, I could just pass in a new object, right? Rather than modifying, the existing code, right? So like when I first started programming, like we were always modifying code, right? But that means we're always creating new bugs by accident, right? But if you do it this way, it's more difficult, to create new objects and all that. But, on paper it looks good. But, in practice, you got to really think what you're doing. Okay. Um, okay. Uh, this is just simple. Stuff facing software engineers based on the current technology. Basically, you have to learn new things, reduce delivery times, right? That nowadays, it's it's a worldwide, since everything is on the internet, it's worldwide competition. So you have to, when your competitor does something, you have to do it also, right? So now everything is AI. Everything became AI, whether it makes sense or doesn't make sense, right? Uh, like Zoom just wanted to do AI. I don't know what they want. Like everything became AI, because that's what your competitor is, AI. Yeah. Developing trustworthy software. Again, that's the same idea. Um, Global competition, that's also true. It's all the above. Guys, it's pretty basic, right? Um, I think I really meant to say secure software. I think that's what I meant with trustworthy. Okay. And I guess this is maybe repetitive, so okay. Um, okay. Uh, okay. Basically, we have this code over here, which I'm not going to do this on the test, but I did in this test. Basically, what's wrong with this code? So basically we have a list of banks, right? And a Bank of Spain, Bank of France, and every time we borrow from a bank, we have two uh, lists and whatever it does, right? So what's wrong with this code? This is basically which design pattern would address this issue? Right, right, because it's two separate types, right? The Bank of Spain and the Bank of France. So we have to have two different loops, right? So what would um so the observer pattern, right, addresses this, right? Well, first of all, what's the problem? The problem is, besides being ugly, that you have to loop through two different lists, right? The other problem is that if we had a third type of bank, right? Let's say we had a German bank, right? Then we'd have to modify this code, right? Yeah.
So, for example, using a while loop and like having one for loop that goes through each list, like as a while until you fall off the end of the list.
No. The solution is that what's observer solution is to see, wait a second, we have Bank of Spain, both of them are implementing an interface. So what we should really have is a bank list, which will include both French and Spanish banks, right? Because if you look above, right, just like in the observer pattern, we had different observers. They all implemented the observer, so then we were able to treat them the same, right? Remember, an interface is a nice trick to use in programming, because it allows us to combine completely separate objects and when they only have one thing in common, right? Then it allows us even though they're completely separate types of, one's a French bank, Spanish bank, and they're totally separate types of objects. One is, might have 2,000 lines of code, one might have, a very small object, and German bank might be something else. But as long as they implement the interface of borrow, then if that's the only thing we're using, so then we could combine them into one list of objects that allow borrowing. Yeah,
So basically, because you're using the bank interface, you can concatenate like the French banks and the Spanish banks to one big list. And
of bank, yeah, one list of bank.
Yeah, I mean, like a list of like all the banks.
Yeah,
in both
exactly, yeah,
items, and then
right.
you have one for just.
Right, we just have one loop, right,
Okay.
exactly. Because as long as they have something in common, they're the same thing in common, then the interface allows us to say, okay, you're the same. For my purposes, which is to borrow, you're the same. I don't care what you are, but if you have this borrow method, join the club. Okay? So that's the beauty of it. So I said it's using inheritance. No, it's using actually composition, right? Um, it should use composition, but it is using composition. That's not the problem. It should use extends. No, that's not true either because it's not inheriting. It's because it can't inherit because this is an interface. What?
It's not a class, it's not like extended.
Well, no, this cannot inherit because bank is not only an interface. You can't inherit it. And in financial statements closed for modification, no, that's the whole problem is that this is open for modification, meaning if I add a new type of bank, right, then I'm going to have to add a new list for it. The answer is we should use observer pattern. Okay. That would be the correct answer. Because observer pattern deals with this type of situation. I just want to see what it is. I'm not going to. Okay. I don't know, is that my problem with hanging up? I have to go like this. I don't know. In Teams, Microsoft Teams, when I get a phone call, I just tap it. It's much easier. But when I get a regular phone call, I gotta go. I don't know. I don't know what maybe I should try tapping it. But usually I gotta swipe like really hard. And yeah, regarding the singleton pattern, the following is true. Oh, this is what we just spoke about, right? We spoke about this on Tuesday. So the singleton pattern, what's the idea of the singleton? Do you remember the idea? Anybody remember what's the idea behind singleton? So let's just say what the is for. So singleton, so the idea singleton pattern, the idea is it has basically actually has two ideas. I only said one, but there's really two. Well, first of all, the name gives it away, is that single, meaning that there's only one object, right? Meaning that a singleton pattern says that it makes sure that there's one and only one object being used. So number one, it's like the name implies, there's only one object. And number two, it basically it protects a global object. Okay, protects a global, no, it's even because normally a global object is not good, right? Because a global object could be changed throughout the program, and therefore it's really hard to know what's going on with the global because anybody could we could have we could have code that's been around for 20 years, and someone else says, hey, let me set this global to, to some number, and all of a sudden, 20 years of code goes out the window because you just broke this, you just set a value for the global, which is going to destroy the rest of the code, right? So it's very dangerous, right? So because it could be changed anywhere in the code to any value, and there's no protection. So the singleton protects the global value from outside modification. Actually, let me just, since I have it right over here, let me just bring it up for a second. We'll just show you the two types. It's on the website also. So for example, over here, we have the get ID, and get ID has this static, which means it's global, but it's private. So the only people that have access to this ID is this method over here, get ID, right? So no one else could change the value of this ID except this method over here. So we're protecting it from anybody sending it to any crazy value. Oh, I forgot to make this private. This is supposed to be private. So over here we have the idea that my internet's unstable. Oh, okay. So over here we have the idea again of the global, which is private, but with over here we see the single idea, meaning that the first time we call get connection, we create one connection, right? And the next time we call it, it won't be null, so we're only going to have one connection, and we're going to return it, right? After the first time we say get connection, we create the connection, and every other time after the first time, we return the connection that was created. Okay, so we only have one connection, right? Just like over here, we have one ID, but over here it's more. You can see more of the idea that it's single, right? The difference between these two is what? Remember what the difference? What's the difference between these two types of singleton? Right. This is, I guess you would call like early binding, meaning that ID gets created when the program loads, and then sometimes you only want to create the single object later on in the program. In this case, we only want to create it the first time it's called, right? So the first time we call get connection, then it might be slow because it's creating the connection, right? But every other time after that, it will reuse it. So it shouldn't take that much time, right? So that's the idea. So there are two forms of singleton, right? The one that gets created on demand, right? The first time we use it, and the other one that's created when the program loads. Okay, so going back here, let's see what we're doing over here. So, okay, okay, so only one object. I should just say only one global object. Okay, so regarding singleton, only one instance of an object. Oh, that's true, right? Because we only have one type of object. Well, we only create one of them, right? Emphasis is on one, right? Protects access to global object, yes, because we make the global object private. C is object can be created the first time it is used, right? Meaning it doesn't need to be created when the program loads, right? We saw that. an object or D, or we have C or D, right? We have, there's two form of singleton, right? One form is it's created when the program loads, and one is the object is created the first time it is used, okay? And so the answer is all the above, right? So we have all those nice things about singleton, okay? Do you remember what the interview question is about this code? Did they ask you? Yeah, what's unsafe about this code?
Let's say,
Why not?
because two people could access it at the same time, then you create two connections as opposed to the one.
Right, no, it's specifically this line over here, line 5, two threads could hit it at the exact same moment. And then, because it's global, right? So is it any, global things could be accessed by any thread, right? Um, and therefore they could actually both call new DB connection, right? So it's not thread safe. And if you look it up in Wikipedia, you'll see different ways in different languages how to solve that. I mean, it's a common problem with any globals when you're using threads, right? It's right. Right. So that you'll see they they synchronize it. They do mutexes. I don't understand all the differences between them, but there's different ways of making it thread safe. Whatever. But that's a job interview question. They'll say, what could go wrong with singleton pattern or something? You know, and the answer is not thread safe because it's global. So any global object is available to any thread, right? So if something's not global, right, then it's only available to the thread that created it, right? Okay, that's a general, okay, if interested, you can look it up about mutex and stuff like that. But we're running a little bit late, so I'll just end with this, and I guess we'll have to continue on Sunday. What? 7 p.m. on Zoom. And until I wear you out, I'll try to keep on going Sunday. So we should be here for a long time. I'll be there a long time. Okay. Any questions you have, just, I guess, okay. So we just did all the above. Okay, 38. Incremental development, customer involvement is not recommended. Nah, we want customer involvement, right? All requirements are determined before coding. No, that's not true, right? Because we do it, every 2 to 4 weeks. We do all the phases, right? Easy to make modifications. Yep, that's it. It is because we're unlike waterfall where we're locked in when we start coding, right? When with incremental, we're every month the example I gave is like for example with waterfall you would you imagine you hired somebody and they painted the whole house a certain color and then you'd change your mind, so that's really difficult. But with incremental, you're painting one wall, you're asking the user, do you like this color? So if they say no, so then you only have to redo one wall, right? Because you have the customer involvement and you're only doing a little bit at a time, right? So instead of doing the whole house at one time, you're doing one wall, then you're doing another wall, and then each time, each increment, we're asking and we're testing, right? So therefore we're not doing a lot of we're not like saying, oh no, we just wasted all that paint on all that time painting the wrong color. Okay, code does not need refactoring, right? That means it doesn't need to be cleaned up. We said, no, it does need. Why? Because every iteration, we're always making changes, right? Because we're keeping adding things, adding more things, and at the time you keep adding things, there's a good chance you're going to have to refactor the code. And then the only testing done is unit testing. That's wrong. We're doing regular testing also. My unit testing is, does anybody remember what it is? It's testing done by the developer, right? Not by the testing department, but with incremental development, we're doing everything. We're doing requirements, coding, we're doing unit testing and regular testing, meaning outside people are going to test it and look at it, right? So we're doing the full thing, but we're just doing it on a small bit of code every 2 weeks to 1 month, every cycle, okay? Every development cycle. Okay, so we'll leave it up at 38 and well, we're getting there. Okay, take a good look. You can ask me questions. Email me some questions if you have any.